Welcome to this week's IGC Events webinar Focus on Geothermal, which is presented by Think Geoenergy and Enerchange. My name is Jochen Schneider. I am the Director of Enerchange. I'm glad to welcome today our guest Jörg Uhde and you everywhere in the world to another Friday Energy Talk. Jörg invites us today to a virtual tour in the geothermal power plant in Insheim. Jörg is a mining engineer from Clausthal-Zellerfeld. He was working for Bauer Resources, the Swiss energy supplier Axpo, and the Stadtwerke Waldkirch. In these positions, he was also involved in various geothermal projects. Since 2017, he is responsible at the Pfalzwerke geofuture, 100% daughter of the energy supplier Pfalzwerke, for the geothermal power plant in Insheim. Jörg, the floor is yours.
Yeah, warm welcome to everybody on this Friday afternoon. I'm quite happy that you're interested in our short virtual tour through our small geothermal power plant in southern Palentina. So Insheim is located in the Rhine Graben, in the Upper Rhine Graben on the western side, where we on the German side have two geothermal power plants. One on the eastern side is the by ENB operated Bussal sites, and we have further sites, the of course well-known Sulzufere R&D geothermal site and the Rittershofen just heat providing geothermal site on the French side in the northern Alsace. I collected all the projects which are under discussion and also under operation in the spreadsheet on the right side. The main message is that the Upper Rhine Graben is looking into a very promising development within the upcoming 4 to 10 years. And by the end, if all the wishes will come true, we might have a lot more, but 10 geothermal sites in this very promising geothermal region, both on the French and in the German side. Coming back to the Insheim project, the project started in early 2007 by a private project development company called Hot Rock Engineering Company. And after the successful drilling of the first well in late September 2008 and a successful testing of this well, the project was acquired by our present owner, the Pfalzwerke Group, which are the public utility company in southern Palentina. And under their obligation, the project was continued with the same team and the same drilling company. The second well has been drilled, and after a very intensive test phase, the flow rates and the injection rate have been tested for both wells. In 2010 has been decided to drill a sidetrack in the first drilled well, the GTI-1, which is our present re-injection well, and which today allows us a very low wellhead pressure on the re-injection side. And in late November 2012, the start of power production occurred. So these are the main technical data of our power plant. We have a brine temperature in the operational phase of around 165 degrees. Actually, the maximum flow rate is about 70 liters per second. By this, the electrical output is about 4 megawatts, and we are able to produce up to 35 gigawatt hours electricity per year based on a very high availability of more than 8,500 hours per year, which are the result of an optimization process and a very high engagement of our operational team in the power plant itself. Without this, this is not possible. Actually, there is no thermal energy extraction so far, but we are discussing several options, and I'm quite optimistic that we will be able to realize a heat extraction solution within the upcoming 1 to 2 years. We have in common with all the other ORC plants in the world, our on-site power plant may rise up to 25% due to the very high power demand of the driving engine of our line shock pump, which is shown on this picture on the left side, and as well for the fans for our air-cooled condensator. The financial basis for these projects in Germany is the remuneration under the German Renewable Energy Law, which guarantees 25 euro cents per kilowatt hour electricity for a period of 20 years. The total investment cost was a little bit more, about 50 million euros for the whole project. We are operating an Ormat organic rankine circuit unit with a working fluid Isopentane, a very reliable technology, which is very successfully being operated for almost 10 years now. The exploration in the Upper Rhine Graben rises up to depth of around 4 to 4.5 kilometers depth. The deepest well has been drilled in the northern Elsass region for the Vendenheim projects. These wells were even deeper than ours, as we have a target depth of around 4 kilometers and reaching then the crystalline rocks or the fractured upper basin. But as well, the upper sedimentary layers, the Bunter sandstone and the limestone are connected to our wells, so we generate the brine stream from 3 different layers. Operating geothermal power plants or thermal brine circuits in the Rhine Graben is mandatory to be operated under a very precise seismic survey. This is shown in this picture. We are not only operating a traditional seismic survey net, but as well we have an additional net for ground velocity sensors. These are the symbols in blue, allowing us to control the ground velocity on the surface, which may be induced by induced seismicity. In our particular region in Rheinland-Pfalz, we have to respect these levels to handle our induced seismicity. The operating range of our power plant is usually under the level 1, only very rarely in level 2, but we always have to keep in mind that the perceptual range for mankind and even nature begins at level 4, so we are on a very safe level and far behind any risks for the public and private infrastructure above ground. Producing brine in the Rhine Graben due to the high temperature demands special pumps, so we are operating line shaft pumps and standard technology not only in our region but especially in Southern California and in some other areas in the world. Once you have solved several technical problems, it is a very reliable system and allows to produce fairly warm brines or hot brines due to the fact that the driving engine is installed above ground and we have only mechanical devices in the borehole installed. Our pump with the 39-stage circular pump is installed at a depth of 750 meters depth in the borehole, and therefore we need a very long driving shaft of as well 750 meters depth. So you may imagine a pump workover, exchange of a pump is a very intense operation and usually takes a couple of weeks once we have been able to exchange a pump. This picture shows the 39-stage stainless steel circular pump, which can be divided into 2 sections due to transport reasons, otherwise it would be too long and couldn't even be lifted out of our site. By operating a brine circuit, we always have to keep in mind the chemical issues and the chemical conditions of our brines, which are shown here with the basic data, especially the carbon dioxide content, which is very high in the Upper Rhine Graben, which differs from 91 to even 95%, and carbon dioxide in the gas phase. And usually we have an average value of 50% volume, 50% volume in our brine, so 50% is water and 50% is gas. Therefore, the brine system is operated on the hot side with an operating pressure of above 20 bars. Therefore, we can assure that we can avoid degassing effects in the brine circuit. Presenting geothermal projects in the Upper Rhine Graben actually is not possible without mentioning the lithium issue. It is well known by far that we have a very interesting lithium content in the thermal brines in the Upper Rhine Graben, different from 150 to 200 milligrams per liter. Therefore, the Upper Rhine Graben belongs to one of the most promising lithium deposits in Europe. And we assume that about 1,000 tons of lithium carbonate equivalents could be generated on a typical German geothermal site from our dimensions. If we have a look in the brighter future, so geothermal sites might be designed in a larger dimension, and then of course the production capacity could be enhanced then. We could provide, of course, for the national and international industry a portion of this strategic raw material lithium once we will be able to have a proper and reliable and feasible technology to selectively extract lithium out of this high mineralized and chemical quite complex geothermal brine. And this will allow, once several questions which are currently evaluated through several R&D projects, both on the German but as well on the French side, will allow a very sustainable and environmentally friendly production of lithium. Once this dream might have come true, our vision could be like this, shown in this very simple scheme. So we would have a very first extraction technology. We could compare it to the oil industry. It would be the upstream process, where we have lithium, a very selective lithium extraction out of the brine, producing a pre-product or pre-concentrate of lithium, which then should be further treated and to produce battery-grade lithium product in a downstream site, which definitely will not be installed on a geothermal site as well, but in the same area of the other geothermal sites. Well, this was a short introduction of our site, and to keep the limited time in vision, so we will now switch over to the 3D tour through our geothermal site. To bring you closer to our site, we will have a look at this bird's view. So our geothermal sites consist of the two wells, which are located here, where we would start the 3D tour. And then we will shift over to the heat exchangers of the organic Rankine unit. We'll have a look through the air-cooled condenser, and we'll have a look as well in the thermal water treatment side, which is mandatory while operating a brine circuit in the Rhine Graben due to the high mineralization. And then we will have a final look from the top of the air-cooled condenser back to our site. So now we are starting on the top of the motor of our brine pump, and have a look now on the wellhead of our reinjection well. But to make it a little bit better understandable for you, so we will start with a look of our thermal brine pump. This is the driving motor of the brine pump, and the hot brine will be pumped through these isolated silver pipes through our power plant, and will return through the red pipes back to the wellhead of the reinjection well. This is a 600 kilowatt engine. We are operating a modified ITT Golds pump. It's already set, installed 750 meters below surface, and constant operation. And in this container, we have a service unit for our brine pump, containing not only the greasing unit, as the driving shaft has to be continuously greased with special grease oil to allow a constant operation, but as well the bearings of the motor are water cooled, and inside this container there is also a water cooled unit to allow safe operation of all these units under any ambient conditions. And now we will jump over to our heat exchangers of the RRC unit. Right in front of us, we have a picture, can see in the picture our spare pump, which will be installed within the next year, and you can see it is divided in two sections just for transport reasons. This is the turbine being operated by Isopentane, which is completely vaporized in this large vaporizer, where we will have a further look later on. And the vaporized Isopentane will flow through this large pipe vertically into the turbine, rotating the turbine, and by this driving the generator here on the right side. By expanding in the turbine. The isopentane is leaving horizontally the turbine on the left side and then will flow into this large air-cooled condenser. We have a large horizontal pipe on both sides of this condenser where the isopentane will be distributed over the complete length of the condenser. It will flow through the opposite side of this picture and will then from there, once it's fully condensed by this production pump, and back into the vaporizer, which we can see on the opposite side from here. Here we have two preheaters where the isopentane, once it has been completely condensed, will be preheated again, and it's then flowing from the lower preheater into the vaporizer where it will be fully vaporized. And this looks from the opposite side. You can see it from here. You can see the incoming fluid isopentane flowing in the upper, the colder preheater, then flowing into the warmer lower preheater, and from there the isopentane is flowing through this pipe into the vaporizer, where it will be fully vaporized, and then will flow over to the turbine. The brine is flowing in the opposite way. It's coming out of the production valve from here, flowing into the vaporizer, out of the vaporizer through two preheaters, and then flowing back into our brine treatment facility, where we will have a look now inside, and then the operation starts the same way. On the left side in these beige blocks, we have the service unit for the sealing, oil sealing unit, and the grease unit for the turbine shaft and the generator shaft, which of course has to be continuously greased. Within our brine facility hall, this is the hot brine coming out of the production valve. We have two filter units where we filter fines out of the hot brine, which we especially need when we have restarted the whole system after a maintenance shutdown for a longer period. Then by restarting the brine pump, fines will be mobilized out of the reservoir and they will be filtered out here above ground. Then before entering the brine into the heat exchangers and the vaporizer, we add certain inhibitors into the brine in a very small concentration to avoid precipitation and scaling effects out of the brine, as we have a very high mineralization in the brines in the Rhine Graben. And for example, with this inhibitor, we prevent barium sulfate from scaling out of the brine, so we can avoid larger amounts of fluids. And on the left side, we have a special product, not only inhibiting other minerals, but as well setting up a so-called corrosion film within the whole piping system. Therefore, we can avoid corrosion effects due to the high salination of the brine very successfully. Actually, we are involved in an R&D project together with the KIT, the Karlsruhe Institute of Technology, and further very experienced partners from Germany, which is a national funded project where we intend to develop further specialized inhibitor products, which can be individual designs on the specific demands of a geothermal project in the Rhine Graben. So the cooled brine, once it has left the heat exchangers, is returning through this red pipe back into our hole. And there we have as well a filter group where we will be able to filter out scaled out minerals, and they will be filtered out, and these filters are in parallel operation, so we can pass by these filters and to assure the constant operation of the whole unit. And these filter residues will then properly disposed of. These oil drums over here are empty, but they contain the grease oil for our line shaft of the line shaft pump, and they are just stored here once the grease provider has taken them away again. So now we will have a look at the control room. This is our control room We have two separate control systems. On the left side, the blue screen is the control screen for the brine circuit, where we are able to control any situation in the brine circuit and gain any necessary data out of the brine circuit. And the light blue screen in the center is the control screen for the ORC unit. We have different technologies behind, therefore we have different control screens. And on the right side we have a data collection system. So any interesting data, especially on the brine circuit, will be recorded constantly. And by this, we have a very interesting data set for now almost 10 years of operation, which are of a high interest for several R&D projects for scientists from different universities. And one interested question always popping up is, are there any further connections and dependencies from the operational data and the measured seismic data which we found by operating our brine circuit? From here, we will now climb on our air-cooled condenser to allow you an overview of our site. Once our slow internet connection might allow us to have a brighter look on the site, brighter look. So here we have the whole number of fans that are constantly in operation. This is the wellhead of the reinjection well. The wellheads of the production and the reinjection well are pretty close by, but of course, as in any other geothermal project as well, we have inclined wells. So the landing point of the reinjection well is over there, and the production well is landing over here. This is a brine storage facility, which is an enhanced mud pit from the previous drilling phase, which was enhanced and with several layers to ensure a very safe storage of the brine, which allows us an easy start of the whole system to cool down and pre-store the brine once before we pump it back into the reservoir. And of course, would be very happy to once welcome you in person on our geothermal site, and then give you an introduction of the wonderful wine area in southern Palatina. We are the second largest wine production area in Germany. And while visiting us, you will see that from this wonderful small vineyard, where a very dry and excellent Riesling is produced, and we have a special selection for our company from there, and all visitors will be welcomed with a special bottle of our selected Riesling wines. So now I come to an end through our vertical tour, and if you're interested in, I would be happy to answer your questions.
So thank you very much, Jörg, for this very nice presentation with a look at the nice scenery in Palatine. This presentation is open for questions, and we already have the first ones. We will make it like this. We will step to certain points. We will answer the questions here and then go to the next area. So we will start with the line shaft pump. Could you please go there? Here is the question: how much costs the line shaft pump, including equipment and installation?
Well, you may imagine a line shaft pump from our dimension with 39 stages and quite a large driving engine has an investment amount of around €500,000.
The next question: what's the requirements on the borehole structure for installing a LSP?
Well, they are not different from installing an ESP, so an electric submersible pump. We need a pump chamber within our borehole at the necessary depth and the necessary dimension. But when discussing further projects, I would recommend to design the well with the maximum allowable diameter, so that you will be able not only to install the pump by itself, but as well to install several information lines, for example, glass fiber cables, which have been successfully installed, for example, at the latest project of the City Works of Munich, which will allow to control the pump by itself, to record vibration data from the pump, to record temperature and water level data.
Okay, thanks. What kind of maintenance work is needed for a line shaft pump?
By itself, the line shaft pump by itself can be operated almost maintenance-free. As I mentioned, it has to be constantly greased, the line shaft by itself. But once the pump is installed and is carefully operated, we expect now for our next overhauled pump an operational period of about 7, maybe even 10 years.
Okay. How long is the lifetime of such a line shaft pump? Why are you going to change it?
Well, in our particular case, there's a design failure in our line shaft pump at the connecting box, allowing to divide the 39-stage pump into 2 sections. It has been designed of black steel within a stainless steel section, and we have the fear that we will have induced corrosion through the connection between black steel and stainless steel, and therefore, as a preventive maintenance measure, we will deinstall our current pump and will replace it by an upgraded pump where this design failure has been eliminated.
Thanks. Do you have casing problem in the production well before brine goes to the separation system?
No, so far not. But as we are obliged to frequently control the integrity of our well, we are constantly, always when we have maintenance operations on our well, so this will occur next year once the pump will be relieved, there will be a very intensive logging program within the production well to control the wall thickness of the casings, the internal diameters, and something like else. But actually, we do not have indications that there might be a wear of the casing structure within the well.
Thanks. The next question, do you have any number for energy loss in your production well regarding 70 liters injection rate? Perhaps there is a misunderstanding. You have no injection rate, you just have a production rate of 70 liters.
Yes, that's the point, but we haven't had a loss of production rate over time so far. But due to the reservoir structure, the basic design values of well, it was indicated to the whole power plant has been designed for a flow rate of 80 liters. This could not unsuccessfully not achieved so far. But we have a very constant flow rate, and we do not have indications that the production temperature has changed over time. So we do not have a connection on the hydraulic or temperature level between the reinjector and the producer.
Okay, thank you. Could you please move to the ORC unit?
Of course, I can. Here we are.
Yes, we have some questions here. What volume of isopentane do you have in the ORC loop?
I actually do not know the volume, but I can tell you the weight. We have about 40 tons of isopentane in the whole system as a working fluid.
The next question, did you already face pollution in the isopentane? If yes, what were the reasons?
So far not. In the past, we had a very slight leakage in one of the pipes of our vaporizer. We have tube and shell heat exchangers, probably it was a material problem a couple of years ago. We had a slight leakage in one of the tubes, and therefore we had a slight water introduction into the isopentane, but this has already been limited by exchanging the isopentane and cleaning it. So therefore, we do not have any pollution of the isopentane so far.
In addition to monitoring seismic activity, does the production site monitor groundwater flow and heat during operation?
Yes, of course. We are monitoring not only the flow rate, the temperature of the brine, both on the production as well on the reinjection side. We monitor the reinjection pressure constantly over time. We monitor and record the speed of the motor, so the rotation of the pump.
Okay. And how the installation affects the groundwater bodies? Do you this also monitor?
Yes, of course, we are monitoring the groundwater level, so the reservoir, not the upper levels, of course. And we have a special sonic system where we constantly measure or control the level above the pump. And this is a very important value, as this allows us to safely operate our brine pump or our production pump, so that we always have a top pressure on our production pump.
Okay, you spoke before that you're monitoring also the brine. What do you monitor regarding the brine?
Well, basically the brine is constantly analyzed, completely analyzed once a year. So we have a chemical consultant who has a special testing device, and so we are sampling, a testing and sampling device, so we are able to sample brines on the hot and on the cold side, so on the production and on the reinjection side. And once a year, we receive a complete analysis of the brine, so all the necessary values, not only the gas content, but also the mineral contents of the brine. But as we are partnering in several R&D projects, so we have further sampling procedures over the year, and therefore have a very interesting and broad databases for our brine over the last 10 years.
If the air cooling system is down by the fans, or is there also water pipes with additives to keep it cold?
Not yet. It's an interesting question, but actually we are discussing to install an adiabatic cooling system to enhance the performance and the efficiency of the air-cooled condenser under certain ambient conditions, especially in the very hot summer times.
There is a wastewater treatment plant in the south of the installation. Does the geothermal plant affect the former at all?
Oh no, we have a close-by highway, that's true. But of course, there are certain construction restrictions when you will install a technical site close to the highway. So we have to safeguard certain distance values to the highway. So we do not affect the highway traffic, as we do not have visible and invisible emissions by operating our site. Only when we restart the brine circuit, we are circulating the brine through our separator once the brine circuit is reheated again. And then, of course, this can be shown by an aerial view. Then we have, for a very limited period of time, so very few hours per day, we have form emissions. And this is just simply pure H2O. It's just simply pure water form. Water steam, it's not form.
So water steam. Do you have a constant level of power production from overseas? Any change in the output in summer and winter since the ambient temperature changes and affects the condenser?
This is true, of course. The higher the ambient temperature becomes, the lower the efficiency of the condenser will be, of course. And this affects the efficiency of the whole ORC unit as well. And to allow successful fluidization of our isopentane under these ambient conditions, we have to reduce the flow rate of the isopentane through the ORC unit. And by this, we will, of course, reduce the power output of the ORC unit. So in very cold winter times, when we have optimal ambient conditions, from our point of view, of course, then the maximum performance of the whole unit might be around 4.5 megawatts. So not very far from 5, but it may be reduced in the summer times down to 1.5 to 2.
Okay, thanks. The depth of the boreholes, please, and costs of the boreholes.
Well, the target depth of our boreholes are about 3,850 to 3,900 meters, so close to 4 kilometers. And you may calculate for the reservoir development around 50% of the overall investment, which has been shown. It has been around 50 million euros. So the investment of the reservoir development was around 25 million euros, including the sidetracks. So by this, you may calculate roughly 12 million euros per well.
Thanks. I understand you may inject chemical inhibitor in the brine. Is it an automated process?
Yes, of course. We have tested out the proper concentration of the inhibitors, and then we have a pump system behind these IBCs you have seen in the brine treatment facility, where we can step back again. And these dosage pumps are frequently controlled by our control system as well. So we have certain dosage pumps. These are these dosage pumps which are once installed and adjusted, and the dosage rate is of course controlled by our SCADA system of the brine system, and as well what the level of the inhibitor containers is controlled, so that we can assure a constant and safe injection of the inhibitors into the brine circuit. Here we are.
Will the gas from the brine be reinjected?
Yes, yeah. We keep, as already said, we keep the whole brine circuit under pressure above the degassing pressure of the gas, the carbon dioxide, and therefore we take care that the carbon dioxide will be re-injected together with the brine into the reinjection well.
Thanks. The question, which company did all the SCADA system as well as the surface piping?
So the whole project was realized by a general contractor, which is a subsidiary of our mother company as well, the Bestec Group. The SCADA system was for the brine circuit was developed and realized by a consultancy from northern Germany, quite successful. So we are very happy with the system even after 10 years of operation. So of course it has been partly updated depending on our individual demands, but it still works excellently. And the SCADA system for the ORC unit, of course, was provided by the ORC unit producer, the Ormat Group from Israel. And the piping system and the whole construction above ground was provided by a local construction company. So the piping system is designed with black steel.
Thanks. The next and probably final question, what makes the big difference to the Landau facility, which is so close and has nearly the same geological conditions?
You may regard the Landau site as the first generation of a geothermal power plant of this kind, and ours at the second generation in our particular area. So even if we are very close by, so the distance is just 6 kilometers, the Landau production well has different conditions, but ours, it is constantly under pressure, so it has an open flow potential. Our production well doesn't have an open flow potential due to the fact that we have a sidetrack in our reinjection well. We have very low reinjection pressure, so we do not need additional reinjection pumps to reinject the brine into the reservoir back. And this is one of the main difference to the Landau side, where the permeability on the reinjection side is not as good as in our situation, and therefore the brine has to be constantly reinjection with the support of a reinjection pump.
Thank you very much, Jörg, for the discussion and the many questions you answered, and also for this nice presentation. It's really nice to have a virtual tour here of a geothermal power plant. I don't know any other plant which can show something live in the web. So thanks a lot also for the questions to the audience. This is the announcement of the next focus on geothermal. And it's about GRMF project. It is by Maria Uelzen from Rödl & Partner. She will speak about the continuation of the GRMF program in East Africa, which is a risk mitigation fund. And here the next round starts with a kickoff in 2 weeks. So looking forward to see you next week again. I wish you all the best for the nice weekend, and thanks to you all, and especially thanks to Jörg for a very nice presentation.
Have a nice weekend all together. Bye-bye.
Don't forget, if you visit the plant in person, you will also get some Riesling there. Bye-bye.
Bye-bye.